Okay, so let's start looking at this. That was the kind of theoretical setup. Now we're going to start looking at specific examples to see how these learning algorithms actually work, okay, under the hood. And we're going to start with very low dimensional models and understand kind of from the fundamental approach what these things are doing. So in this case, I made a kind of dummy data set. And this is a one-dimensional data set, okay? It has some x values and y values, okay? So we can plot each data point on an xy graph. Our feature set is just x values, so it's one-dimensional. And our target value set is the y data. And for this case, I actually sampled these data points off of a known function. This is a simple cubic, okay? Each y is just x cubed. And then plus 3 just to break symmetry a little bit, okay? So the interesting thing about this is we know the model. And what we're going to do now is start to apply machine learning algorithms to kind of reverse engineer our model that we know. So the basic case scenario is not only will our system predict these values, but will tell us what the model is. We know it's cubic, right? Does that make sense? Don't think of this as a graph of anything. It's just data that has one descriptor, x, and one result, which is y. And we're just plotting these values on a two-dimensional grid. And this is, I'll share these slides later. In all of these, I have a bit of Python code. This one will give you the whole way there, but just to show you the key things I'm working with, you can recreate this later in Python. And we're already going to start using the scikit-learn library, which we will use for machine learning in this class. So here I have this basic function. I create an array of x values, and then I evaluate that function for all x's. That generates the y. See this notation here, big X, small y? And then I'm just plotting them, okay? So now we're going to start modeling this data set and learning from it using this learning system, okay? So in this case, what I have here is this line. I specify, you see here I'm importing scikit-learn, and I'm specifying a model. This is the model that we're going to use and train based on our examples. And it's going to derive some kind of structure, and then we can feed in more results from it, or more data into it, okay? So what I'm doing here is specifying a polynomial model, okay? And polynomial will just create best fit curves of a certain degree, all right? And here I'm specifying the degree. So here we start with a degree 0 model. This is a constant, right? It doesn't vary with the data, but it gives us the best constant. Here it's something like 3. The best constant, which models the data as good as possible with one number. And that just gives us the mean, right? The mean of the results. It doesn't vary with the data. So there's a limit to how well it can model. It's a pretty shitty model, right? And you can see the performance is based on how well it predicts. So these points it predicts extremely well, these not so much, and you can imagine as the model goes, it's going to predict worse and worse, okay? This is degree 0. Now we can start making the models more complex by adding degrees, right? And this is just the case of a polynomial. It's going to, now it can create any line. This is the best fit curve that everybody knows, right, from Excel. A best fit curve is actually a single degree polynomial model, right? And it's going to try to create the single line, and this now varies with x, but only linearly. The single line that fits this data the best. It's a little bit better, but it's still not that great, right? And we can keep going on. And as we add degrees in this specific model, what we're doing is creating more complex models. They can model more data or more complex relationships, right? And we know our model, again, it's a cubic, right? It's a degree 3. But let's just go through this. Degree 2, now it can model a quadratic curve, a parabola. Maybe fits some data a little bit better. Finally, degree 3, it models the data perfectly, right? Here we've just specified the exact model that we already know our data was based on. So we just recreated the model we knew, okay? But just to show you that the exact types of models we're going to be using are not anything mystical, okay? They're the same things we've always used about linear regression and best fit lines. The issue with machine learning is that we can just use more and more complex models to model more and more complex data relationships, okay? So not everything obviously is linearly related, right? So now we can use not only higher order polynomials, but other types of algorithms that we're going to get into. But this is the basic concept. It's just fitting a model to data, okay?